In this NRA project, we are building a decision support tool delivering feasible and efficient CTOP traffic management initiatives. This video explains our overall approach and powerful near-term tools that have emerged from our intermediate results. We use weather, traffic, and airspace models to forecast congested airspace in the national airspace system. We then use our clearable routes network to find feasible rerouting solutions to resolve the congestion. This powerful technology provides valuable tools for today's traffic flow management specialists as we develop the longer-term CTOP decision support tool. Our weather models forecast airspace permeability using a scanning technique. The scan lines align with the traffic flow direction and determine the fraction of available airspace. We also account for the storm height. We add a safety buffer to see if the traffic can overfly the convective weather. This chart shows the permeability forecast over several hours for several northeast sectors in the presence of heavy weather on April 19, 2019. We have automated our permeability forecast, and the real-time data are continuously imported into our NAS Flow Advisory Manager, or NFAM tool. NFAM is a comprehensive traffic management decision support tool for evaluating, modeling, and implementing multiple types of traffic management initiatives in an integrated framework and is ideal for our CTOP application. In addition to weather forecasting, we also forecast traffic levels using well-established traffic models to produce probabilistic traffic loading forecasts. We next combine the weather and traffic forecasts to predict airspace congestion. Accounting for the forecast uncertainties, we identify time periods when sector loading significantly exceeds the weather-impacted capacity, such as this example of Kansas City Center Sector 26 from 15 to 1700 hours, where the loading distribution overlaps or exceeds the capacity distribution. Forecasted airspace congestion can be resolved by delaying or rerouting traffic, but what routes are available? We use historical traffic data to construct our clearable routes network, a database of commonly used route segments. We use the clearable routes network to construct the set of routes available for rerouting traffic around forecasted congestion, and to construct a trajectory option set, or TOS, for each flight. We conducted a highly successful industry webinar to explain this use of the clearable routes network and gathered feedback from NAS users. These elements are the foundation of our CTOP solution, but they also provide a powerful near-term tool for specialists managing airspace congestion using airspace flow programs or strategic reroutes. We implemented these tools in NFAM, as shown here in a replay of June 18, 2019. NFAM receives swim data for TFM flight and flow information. It also receives weather, as shown here, for a 3-hour period for the Atlanta Center, ZTL, and neighboring centers. NFAM also receives the forecasted sector permeabilities, as shown here, over the same time period. The color codings illustrate the permeability level and how they evolve. We can also display the forecasted sector congestion levels, again using color codings to indicate sectors where the loading is forecasted to significantly exceed the permeability. For example, Atlanta Center Sector ZTL 42 has a particularly high congestion forecasted in the 1900 hour when the weather intensifies and its permeability reduces to 59%. To resolve this airspace congestion, we selected the congestion time period and then run the traffic solver. The result is our heat map. Using the clearable routes network, the heat map shows how traffic needs to be managed to solve the congestion problem. Blue indicates routes where traffic levels must reduce. That traffic moves to the routes shown in green. Note, the solver ensures those green routes and sectors are not overloaded. We can turn on the sector boundaries and see how the solver shifted the sector loadings. Blue indicates sector loading reduction, and green indicates sector loading increase, but within capacity limits. Now we know what the solution looks like, so we can create an FCA to achieve the solution. We first select the FEA drawing tool as shown, and in this case, draw the FCA from one green area to another green area, bridging them with blue in the intervening region as shown. we can add specifications for the FCA such as altitude limits, start and stop time, and any flight filters we may want. Finally, given the FCA, we compute the needed traffic rates across the FCA to achieve our solution. The rates in 15-minute time intervals are now shown in the lower right table. We also show the important solution metrics, giving the number of flights transiting the FCA that contribute to the congestion problem, the number of flights transiting the FCA that do not contribute to the congestion problem, and the number of flights not transiting the FCA that contribute to the congestion problem. These valuable metrics indicate how efficiently the FCA geometry and specifications solved the congestion problem. For example, we can adjust the FCA flight filters to improve the metrics. Traffic management specialists can also use the heat map to select strategic reroutes or playbook plays that might work well to resolve a congestion problem. By inspecting the heat map, the specialist can see what reroutes will work. These tools help solve traffic management problems in today's environment and are foundational in our CTOP solution, where we expand on these methods. We automatically generate the FCA and traffic rates and model how users will respond to the CTOP initiative with their trajectory option set. This research is funded by the National Aeronautics and Space Administration and is being conducted by a team led by Mosaic ATM. Continuation of the research will ensure that these important improvements to air traffic management can be used in practical ways, are understood by the people who use them, and result in significant improvements in the operation of our national airspace system.